All right, here we go. I felt like to my viewers that this needed to be looked at pertaining to NASA in space excavation. So please listen to this program.
Hi, welcome back. We may not look back on the decade that we're in as a renaissance in space achievements. In 2012, Voyager 1 left our solar system, the first time any human object made that 11 billion mile trip. In 2015, the New Horizons probe beamed back the most detailed pictures and data on Pluto to date. And a year later, the Juno space probe did the same thing for Jupiter, giving us stunning new images and deeper understanding of the gas giant. In 2018, NASA successfully landed the InSight probe on Mars, tasked with looking at the interior of the red planet. And just days into the new year, China's space agency landed its own probe on the little examined dark side of the moon. Joining me now, NASA Administrator Jim Bridenstine, who directs the agency, grabbing so many headlines lately. Administrator Bridenstine, good to see you. Thank you for being with us.
Thank you. It's great to be here.
We are space geeks on this show, and there's a lot of stuff I want to talk to you about space, but I want to talk about something else first. NASA is just one of several government agencies that is sounding the alarm louder and more frequently now on climate change. NASA's Earth Sciences program is particularly good at measuring and tracking how the world is warming. We really rely on groups like NASA to figure this out and bring it to the fore and treat it very seriously. Have you been able to speak to the president about this and about the steps that we sort of need to think about to mitigate the effects of climate change?
So yes, the president and I, we've had conversations about everything related to NASA, but in this particular case, NASA, we are sensing the Earth in every part of the electromagnetic spectrum, and then we're making all of that data available to the public, data and information. That's what NASA does. Yeah. Now, I want to be clear, because this is something important for me as the NASA administrator to make people aware of. NASA does not get involved in making policy prescriptions. What we do is we do science and exploration, discovery. We use our assets to study the data, and we make everything available to the public so that other people, policymakers, can make decisions. But that's really not what NASA does. But we will continue absolutely to study the Earth. It's important to note also that the president's budget request for the Earth Science Division of NASA has been very, very strong. He is for studying the Earth. It's also important to note that just last week, NASA got its largest Earth science budget in its history, and that's with strong bipartisan support. So it's really a good news story from this budget experience.
All right, so you think that NASA's commitment to studying Earth sciences is going to be something that is going to stay steady? The funding for it will remain?
I think absolutely. I see strong bipartisan support for it, and this budget cycle demonstrated it in a very good way.
All right, let's talk about commercial space first of all. You have been in your legislative days. You have been a strong supporter of the commercialization of space and understanding the role NASA would have and commercial space. Where do you think we are in that continuum?
It's a great question. So what we're interested in is anywhere there is a robust commercial marketplace, NASA wants to be one customer of many customers. Low Earth orbit is a good example. And we want to have multiple providers that are competing on cost and innovation. In other words, this will drive down our cost for access to space and increase access to space. And so right now we are resupplying the International Space Station with what we call commercial resupply. And we have, this year, we're going to be launching American rockets with American astronauts from American soil with what we call commercial crew to send our astronauts to the International Space Station. When we do this, then we can use the taxpayer resources to do things for which there is no commercial marketplace yet.
Right.
For example, going to the moon and studying Mars and studying Jupiter and Pluto, as you identified.
Which is a great use of NASA. Let things that commercial enterprises do, let them handle that, and NASA can sort of take us to the next frontier. Let's talk about Mars then. Landing the InSight probe on Mars was a big moment for everyone at NASA. What are you learning from InSight, and how is it laying the groundwork for the possibility of a human mission to Mars?
So wonderful question. So what we're trying to understand is the history of Mars and its geology with InSight. So between the InSight lander and the Mars Opportunity rover and the Curiosity rover, which is currently operating on the surface of Mars, we know a whole lot about Mars that we didn't know even 10 or 15 years ago. Number one, Mars used to have a strong magnetosphere that protected it from radiation in deep space, the radiation that comes from the sun. Because it had that, Mars had an ocean in its northern hemisphere. In fact, 2/3 of the northern hemisphere of Mars was covered in an ocean, and it had a thick atmosphere. In other words, Mars was habitable. I'm not saying it was inhabited, but it was habitable. As of right now, because of recent discoveries on Mars, we now know that there are complex organic compounds on the surface of Mars. That doesn't guarantee that there's life, but the building blocks for life are on Mars. And those building blocks do not exist on the moon. Of course, they exist on Earth and they exist on Mars. So we're learning more about whether or not there either is or was at one time life on Mars. But it's not just about that. We now know that there's liquid water 12 kilometers under the surface of Mars. Liquid water. Anywhere there's liquid water on Earth, there's life. So what we're trying to discover is life on a planet that's not our own. But here's the other thing that I think is critically important for everybody to know. Over 1 billion years ago, Mars lost its magnetosphere. It lost its ocean. It lost its atmosphere. And so by studying Mars, we can get insight into how Earth's atmosphere is changing and ultimately make, I think, better determinations as to the direction Earth is going by studying the history of Mars.
Do you see, is there a timeline that you guys talk about over at NASA about when we might see a human mission to Mars?
Yes, we're looking to target the mid-2030s. There's a lot to be done between now and then. But what we're doing is we're going to the moon under the President's Space Policy Directive 1. We're going to the moon, and what he said is we're going to go sustainably. In other words, we're not going to go to leave flags and footprints and not go back for another 50 years, but we're going to take international partners and we're going to take commercial partners. We're going to go sustainably with humans and landers and rovers and robots. Ultimately, we're going to retire risk, prove technology and capability, and as much as possible, develop the technologies that can be reusable at Mars. The difference between the moon and Mars is that the moon is a 3-day journey home. When we go to Mars, there's only once out of every 26 months when the Earth and Mars are on the same side of the sun. So when we go to Mars, we're going to have to go to stay for at least a period of 2 years. So between now and then, we have to prove all these technologies at the moon, and we're doing it with a coalition of international partners that are joining us in this effort.
And you're talking, I mean, look, we've got the X Prize, they've got a lunar project going, Google's got lunar work going. You've talked about permanent moon bases, right? A reusable Earth to moon infrastructure.
That's right.
What do we get out of that? I mean, one of the exciting things about space is all the stuff that happens that we end up using in our daily lives that we don't think about. Are we talking about getting resources from the moon that we can use on Earth?
Absolutely. So in 2009, NASA made a discovery that there's hundreds of billions of tons of water ice on the surface of the moon. Water ice represents air to breathe, oxygen. It also represents, hydrogen and oxygen, water to drink for life support. And it represents rocket fuel. So hydrogen and oxygen, when water is cracked into hydrogen and oxygen, put into cryogenic form, that's the same rocket fuel that powered the space shuttles. It's the same rocket fuel that will power the Space Launch System, the largest rocket system ever built that is under development at NASA right now, looking for a first launch in the year 2020. So we have a lot under development right now to go back to the moon sustainably with international and commercial partners.
Jim Bridenstine, I think you have one of the best jobs.
In other words, they're going to go with the intentions of mining the moon towards getting these minerals that are not found anywhere else but other than the moon, of being able to make rocket fuel. And I'm pretty sure, looking at the forecast on down the road, they're probably going to set up some sort of triage unit on the moon. That way, every 2 years, they can pursue in going back and forth to Mars. From Mars to Earth is probably more like I'm just assuming, I don't even know, timeline. If I was to speculate and say it was a 30-day journey or a 6-month journey, I would only be assuming that, because I really don't know. I don't know what the journey is day-wise, from a 3-day journey from the moon back to Earth versus a journey from Mars back to the Earth. But the bottom line is this. This is the bottom line. I think the Homo sapien race realizes that, yes, this planet is dissolving. This planet is developing its own sicknesses because of man, pertaining to global warming and other types of clear signs that we have done something obviously to the earth, and because of it, more and more people are looking towards space as excavation of leaving the planet Earth and possibly developing a new genesis or a new population of people to live in other parts of the galaxy other than living here upon to the Earth. Now that's my assumption, and I didn't want to go too far out there in speculating different things, but there is an enormous amount of concern just within the past 2 years that we are adventuring in space, going where no man hath gone before, similar to the Star Trek logo.
Jobs in the entire world.
I agree with you.
So thank you for joining us. Great to talk to you,
Thank
sir.
you.
Let's make it a more regular
Always.
thing.
Absolutely.
Jim Bridenstine is the administrator of NASA. All right, coming up next, the race for 2020. A new report says former President Obama is quietly giving advice to some Democratic candidates. We're live in Iowa as contenders hit the trail on this President's Day. And as we get closer to tax day, we're getting more information on how America's biggest companies are faring. Amazon made more than $11 billion in profit last year. Guess how much it's going to pay in taxes? Zero. Netflix racked up its largest profit ever last year, $854 million. Its tax bill? Zero. We're going to keep watching stories like these in the coming months. You're watching Velshi and Rule live on MSNBC.
See what I'm saying? The rich keep getting richer, and the poor keep getting poorer. All we are is statistics compared to the conglomerates, the wealthiest of the wealthy, the powerful, the rich. Going where no man hath gone before. Welcome to the 21st century. Good luck to all of us. Good luck to each and every one of us here up onto the planet, especially those who are striving towards living a righteous, holy, gracious lifestyle in the name of the Lord Jesus Christ of Nazareth.